Hello everyone. So today we will be discussing the complete mole concept of for NEET and JEE, okay, using top 15 questions. Top 15 PYQs I have selected. So using these questions we will look into the mole concept topic, okay. So now once after completing this session you will definitely feel like you have learned something new, okay, and also you feel confident about the numericals of this mole concept. So I suggest you to follow the session till the end so that you will benefit out of it, okay. So now before starting this session I just wanted to tell you about our new long term batch announcement that will be starting from 1st July, okay. So from 1st July we will be launching our new long term course for both NEET as well as JEE. Separate batches are there, so where we will be focusing on one-on-one student interactions, okay. We will be covering all the topics, okay, and we will definitely make the difference what you have learned before and what you are going to learn from now onwards, okay. So if you wanted to know more information about these particular batches for NEET and JEE, for NEET 2026 and JEE 2026 as well as EAP 2020, EAP set 2026, just contact to the mobile numbers which are scrolling on your screen, okay. And now let us begin our session here. See, the very basic question here we have from JEE Mains 2020. See, I have collected together JEE and NEET questions together to solve in this particular session. See, the question says the average molar mass of chlorine is 35.5, okay, 35.5 gram per mole. The ratio of Cl35 and Cl37 in naturally occurring chlorine is close to. So what you need to know, so when chlorine is extracted, so from this we will be getting, so we will getting all the combination of all the isotopes that is available for chlorine, okay. So for chlorine we have two isotopes, one is Cl35 and other one is Cl chlorine 37. These are the two isotopes. How do they differ? They have same number of protons but they differ in the number of neutrons. Here we have mass number 35 which is proton plus neutron, and here 37 as a mass number. These are the two isotopes possible for chlorine. Hope it is clear. Now what is the percentage of abundance for chlorine 35 and chlorine 37 we need to know. So by considering all the atomic masses of the particular all the isotopes available for particular element, together we are saying average atomic mass as this much. So 35.5 is the average atomic mass of this particular chlorine. Now how can we calculate average atomic mass? See, whenever they are asking for average atomic mass, take average atomic mass, average molar mass or atomic mass, whatever they are saying here. So average molar mass or atomic mass, both are same here. Molar mass formula is same for both, okay. So take here the percentage abundance. So sum of the percentage abundances, it means in the nature what is the percentage of this particular element, this particular isotopes, and what is the percentage abundance of this particular isotope, like that we need to consider. So summation of percentage abundance multiplied with its molar mass divided by 100. So this is what the formula you need to use. So I will make it more clear, just follow here. See, percentage abundance for Cl35, let us say this as X is the percentage abundance. See, out of 100 Cl35 existence is how much percentage is X percentage, and for Cl37 this will be 100 minus X. So that here I am taking 35 for this isotope into its abundance is X I am saying. So we need to find this X value, okay, plus, okay, 37 is another isotopes. What is its percentage abundance? 100 minus X. So total abundance you can take 100% like this. So what is its average molar mass they given? So here you can take 35.5. Like this you need to substitute in the given formula. Now try to simplify this. So if you simplify, what you will get? So 35.5 into 100, this is 3550, right? So this will be 35x plus this will be 3700 minus 37x. This is what you will get here. So by simplifying this you will get 3700 minus 2x. Here it will be like this. Okay, then next, so you will get 3700 minus 3550 equals to 2x. So from this, how much you will get? So you will get 1500, right, equals to 2x. So now what is the value of x? So x value is 75. It means Cl35 percentage abundance is how much? 75%. It means if you extract total chlorine from the earth crust, for example, so in that, what is the percentage of Cl35 isotope? It will be 75. And for this, 100 minus 75 means 100 minus x means 100 minus 75, this will be 25. So what is the percentage or what is the ratio for Cl35? Cl35, it will be 75. For Cl37, it will be 25. Okay, so what is the ratio? So you will get 3:1 is the ratio of their abundance. So this is how you need to calculate. So where do we have like this option? So we have option 3 as your answer, 3:1. Hope this is clear, right? So if it is clear, just click on the like button. Yeah, let's move further. So here we have a question based on oleum, labeling of oleum. A sample of oleum is labeled as 103%. 103%. What is the percentage of free SO3 in the sample? So oleum means what exactly? So oleum means it's a mixture of H2SO4, sulfuric acid plus sulfur trioxide, SO3. So this mixture is called what? Oleum. Okay. So when this reacts with water, combines with water to form sulfuric acid, complete sulfuric acid formation taking place here. So what you need to understand, here we already have sulfuric acid. It means this sulfuric acid will not react here with water, but here sulfur trioxide is there now. So this is the component which is reacting with water and converting into sulfuric acid like H2SO4. So whatever the free sulfur trioxide is present here, that will be converting into sulfuric acid. Okay, so in this, what is the component reacting? Sulfur trioxide only. Okay. Now, what is the ratio, the stoichiometric coefficient? So 1 mole of this, see 1 mole of sulfur trioxide react with water, okay, and forms H2, 1S and O3 here and 1 here, SO4, like this 1:1 mole ratio, stoichiometric ratios we have. So 1 mole of sulfur trioxide we react with 1 mole of water molecule to form 1 mole of sulfuric acid, you should understand. Okay, so this will remain as such in the reaction, only sulfur trioxide will participate in the reaction, should understood like that. Okay, so now what they mentioned in the question, they have mentioned this as, see, 103%. It means a sample of oleum. So on this oleum bottle, it is mentioned as 103%. So what does it indicate? 100 grams of this mixture, 100 grams of this oleum react with water to form 103 grams of sulfuric acid. This is the meaning of this labeling. 103% means what? 100 grams of this oleum mixture react with water and forms 103 grams of sulfuric acid. By observing or by looking at the law of conservation of mass, so what is the weight of water should be taken here? This is 100 grams, this should be 3 grams, therefore overall mass will be equals to 103 grams. So this is what you need to understood from here. Hope it is clear. Now I am asking you one more question here, just you need to understand this percentage labeling. Okay, a bottle of oleum mentioned as 109%. So what does it saying? 100 grams of this oleum reacting with water to form 109 grams of sulfuric acid. This is what you need to understood. Okay, it means what is the mass of water taken here? So mass of water taken here is how much? It is taken as 9 grams. So that 100 plus 9 gives 109. So this is based on again law of conservation of mass. Okay, so like this you should understood this percentage of labeling. Hope this is clear now. Yeah. Let us make it more clear and more simplify this. Okay, so now 100 grams of this oleum which is labeled as 103% means what? 100 grams of this oleum reacting with 3 grams of water to form 103 grams of sulfuric acid. Okay, it means 1 mole, let us write this as separate to understand it more clear. So 1 mole of water react with 1 mole of sulfur trioxide in order to form sulfuric acid of 1 mole. Okay, so from this what you should understood, so 1 mole required 1 mole of sulfur trioxide. It means 1 mole water weight is how much? 18 grams. No? So 18 grams react with 80 grams of sulfur trioxide. Why I am writing 80 grams? This is a molar mass of sulfur trioxide. Okay, so but in the given question 103 means only 3 grams of water is given. No? So 3 grams of water will react with how many grams of sulfur trioxide? So whatever the value you will get now, that is the free SO3 present in this mixture, that's it. Okay, so whatever the X value you will get here, that will be the free SO3 present in this oleum mixture. Free SO3 means whatever you will get the answer here, that is your answer. Okay, so how can you take this? So take, see, X into 18, so 18X, okay, equals to 80 into 3, like this you can take. So this will be 3 6 are, so X will be 80 by 6 you can write. So this will be how much? So this will be, look here, so you will get around 13.66, 13.66 is your answer. So what is the free SO3 present in this solution? It is 13.33, 13.33 will be your answer. So this is how you need to solve. Now I will be asking you one question. So can you answer this? What is the percentage of free SO3? See, this is the grams of free SO3 present in the oleum, this label oleum 103% oleum, and this is also considered as free SO3 present in the labeling, in this labeling. So my question is for you is 109% of oleum is given. What is the free SO3 present in it? What is the free SO3 present? What is the free SO3 in it? So I want answer for this in the comment box. So I hope you will definitely answer this by observing this concept. Okay, use this and tell me answer for this particular question in the comment box. Feel free to express your answer. I will be looking into it. If you do any mistakes, I will guide you how to do that. Okay, right. So do it, take a screenshot and make your notes and tell me answer for this in the comment box. Let us move further. And here we have a very basic concept, basic question based on mole concept. Tell me. See here, 16 grams of methane is given. List 1, list 2 we need to match. How can we match this? See, 1 gram of H2. It means how many moles of H2 here? NH2, number of moles of H2 will be equals to, given 1 gram, its molar mass is 2. It means 1 by 2. So this is half mole of H2 is given. What they given? Half mole of H2 is given. Okay. So as per this, we know H2 molar mass is 2, that's why here I taken it as 2 in the denominator, so that we will getting half mole. So half mole of H2 at STP occupies how much volume? 22 half mole. See, 1 mole will occupy 22.4 liter, means half mole means you divide this by 2, it will be 11.2 liters, right? So 11.2 liters. See, 11.2 liters. 22.4 I am writing 11.2. So this is what I have taken. See, this value is nearest to this. So B4 I am taking, so that we can get one answer. So B4, and the next 1 mole of N2. What is the weight of 1 mole of N2? So it will be 28 grams now. So it will be how much? 28 grams. 14 plus 14, 28. So you can take C1. So I am matching here B4, C1 like this. Okay, then next half mole of SO2 you have. See, SO2 means what is its molar mass? For sulfur it is 32, for oxygen also 2 into 16, this is also 32, total 64. This is a molar mass, it's a mass of 1 mole of substance, molar mass. Okay, 64 is a molar mass of 1 mole of substance. Here how many moles they mentioned? Half mole. So divide by 2, half mole means half into 64, you will get how much? 32 grams you will get. What is the weight of 0.5 mole of sulfur dioxide? So that will be 32 grams. So D3. So D, your 3. Okay, next 16 grams of methane means, so 16 grams of methane is nothing but number of moles of methane you find first. So it will be given weight is 16, its molar mass also, this is also 16 plus like 12 plus 4 hydrogens means 4 into 1. So total it is also 16. 16 by 16 you will get 1 mole of methane given. So 1 mole of methane, so as per this 1 mole of methane contains how many atoms of this carbon and hydrogen? So you will be having Avogadro number of methane molecules now. So Avogadro number means what? 6.022 into 10 power 23 methane molecules are there. In one methane molecule, carbon has 6 electrons and hydrogen has 4 electrons, total 10 electrons. So in 1 mole of methane you will get Avogadro number into 10, total this many electrons are present. So I can write it in simpler manner, 60.22 into 10 power 23 are the electrons present in this 16 grams of methane. So you have option A as your 2, right? So based on this, so A2. So based on this you can match. So A2, B4 only one option, C1, D3. So your answer 2 is your answer. Hope this is also clear now, right? Let's move further. So can you answer this question? See, I have explained the same question in my short videos of this channel. See guys, if you follow the short videos, you will be covering most of the important concepts within 1 minute or within 2 minutes. I will be explaining the shortest way of a particular concept. See, this question you can solve in number of ways. The simplest way I can say that as the principle of atom conservation, PYQ method. So what is this PYQ method? See, even if you don't know how to balance this equation, in this particular question they have given a balanced one. Even if they haven't given this balanced equation, they just mention this value also, we can easily solve. Now I will show you how to do that. See, read the question. For the following reaction, the mass of water produced from 445 grams of this particular compound. Okay, so now this complete compound will be converting into, see, hydrogens to produce water we are getting only from this particular molecule now. So it means total hydrogen atoms in this reaction has to be conserved. It means whatever the hydrogen mass present here, that should be converts into water in the product side. So I am applying PYQ to hydrogen atoms. Okay, so how many hydrogen atoms are there in 1 mole of this? We don't require any balancing equation. How many hydrogens are there? 110, right? So you can take number of moles of hydrogens are 110. So I am taking 110 into these 110 molecules present, atoms present in this compound only now. So 110 into number of moles of C57 H110 O6. This will be equals to, next this side how many hydrogens are there in the water molecule? I am not balancing. We don't require any of this coefficient. Just simply we can do this. Follow this clearly. Okay, this side how many water molecules are there? Like see, in one water molecule 2 hydrogens are there. 2 into number of moles of water molecule. That's it. So this is the concept you need to use here. This is what we can call principle of atom conservation. So 110 into what is its number of moles means what? Given weight by its molar mass. What is the given weight? 445. So what is its molar mass? For this if you do, you will get 890 is the molar mass of this particular substance. How can you do? So just 57 into 12 plus 110 plus 110 into 1 and 6 into 16, like that if you solve you will get 890 as your molar mass of this compound, which is equals to 2 into, we need to find the mass of water produced. It means weight of water we need to find here. Okay, now what is the molar mass of water? We know it is 80 like this. Okay, so this will be 2 times. Okay, and this will be 9 times and here 55. Okay, so 55 into 9 will be gives what? Weight of water produced here, weight of water. So this will be how much? So 998 once again 495 will be your answer. So 495 will be the answer, or 495 grams of water is produced during this process. Okay, so you have here 495 as your answer. So that is what you need to apply. This is the POAC concept you need to do for this kind of questions. Hope it is clear, and you can also use normal traditional method. What is that? Like stoichiometric coefficients, using the stoichiometric coefficient. 2 moles of this product is producing 110 moles of water. Based on that also you can solve. Okay, both are gives you perfect answer, but this is a method you can use for this kind of questions without balancing. Even they haven't given any balanced equation also you can apply. Hope it is clear, and make a note of it and try to solve this concept for other questions also, so that you will get more clarity on this. Now can you answer me? Can you answer me? What is the mass of carbon dioxide produced, CO2 produced from the same question? Same, everything is same. What I am asking? Mass of CO2 produced in this reaction. I want answer for this in the comment box. So I will look into it and I will guide you. If it is wrong or right, I will tell you how to do clearly. Okay, based on your response. Okay, let's move further. Yeah, so here we have one more question. The question says, if the concentration of glucose in blood is 0.72 gram per liter, molarity of glucose in the blood is, see they given 0.72 gram per liter. See, gram per liter, whenever you see this units, you should consider this as strength of solution. What is this? Strength of solution. So this is also like a concentration term. Okay, the term used for expressing concentration. What we can say, this is also a strength of solution is also a concentration term. Something like molarity, normality, like that we have this one. Now gram per liter is a unit of this strength of solution. Okay, now what is the unit of molarity? Once check, molarity units are mole per liter. Mole per liter is a unit of molarity. Now we need to interlink these two so that we will get the answer very quickly. Okay, so how can we interlink these two? See, molarity, I want molarity and strength of solution relation. See, we know strength of molarity is nothing but number of moles and volume of solution, right? So now solution, volume of solution in liters. Now I can write number of moles as given weight by its molar mass into this volume is there, no volume I am writing. This should be in liters. So given weight will be in grams, volume should be in liters, molar mass will be gram per mole, right? These are the things we have. Now I just want to write weight grams by its volume, volume in liters. See, gram per mole we have multiplied with its molar mass, 1 by its molar mass, gram per mole. Okay, like this. See, weight by volume. So weight by volume is nothing but gram per liter na. So weight by volume in liters, I can write strength of solution. So we got a relation like this. Molarity equals to weight by volume means strength of solution divided by its molar mass of that particular solute. What will it gives? It will give us molarity. So this is the important relation you should remember. Okay. Hope it is clear how we got this particular relation. So now what is the strength of solution? They mentioned 0.72 gram per liter by what is the molar mass of glucose? 180, right? Gram per mole. Okay, so this gram cancelled, so we will be having mole per liter as a unit of molarity. Okay, so finally we can write 72 by 180 into 10 power minus 2 I can write. Okay, so see the options, see the question here. They wanted to express answer in 72 like 10 power minus 3 means I can add 1 0 here. So these zeros cancel, this will be 4 times. So 4 into 10 power minus 3 will be your answer. Hope this is also clear na? Yes. Hope it is clear, and if it is clear, just click on the like button. Yeah. So take a screenshot if required. Yeah. So next, let's move further. So look into it. Consider the complete combustion of butane. The amount of butane utilized to produce 72 grams of water. So just now I told you how can we apply principle of atom conservation. Use that concept to solve this question. You will get answer very quickly without any confusion. See, butane na, so I am not balancing, just writing the formula. So butane means C4H10, okay, plus oxygen, combustion takes place to produce CO2 plus water. See, I haven't balanced equation, I just written that equation, right? Now how many hydrogens are there here? So 10 hydrogens na, so 10, what I am doing, I am applying POAC to hydrogen atom. So 10 hydrogen atoms, so 10 into number of moles of butanes, C4H10 I am writing, equals to this side, how many hydrogens are there in the water? So 2 into number of moles of H2O you should write. Hope clear it is. So 10 into what they mentioned, molar mass of butane as 70, given mass of, in order to produce 72 grams of water, it means you should take 2 into 72 grams of water, given weight is 72, its molar mass is 18, okay, and what they are asking, consider the complete combustion of butane and amount of butane, weight of butane by its molar mass. What is the molar mass of butane? So 4 means 48, 4 into 12, so 48 plus 10, 58, so you can take here 58. So this will be 4 times this 2, this 5, okay. So what will be your answer here? So you will get weight will be equals to 58 into 4 by 5. So you can simplify, you will get an answer, you can write in this box. Hope this is also clear now. Yeah, so we will see one last question of this particular session which is very helpful, okay. So this is also clear. One last model we have, which is important model again. See, this is based on a percentage yield. So just look into it first, read the question first, so that you will get some clarity, and I will explain you. In the above reaction, see, benzene is converted into nitrobenzene. So we can consider this as nitration of benzene. So in the above reaction, 3.9 grams of benzene is given, 3.9 grams of benzene, or nitration gives 4.92 grams of nitrobenzene, okay. The percentage yield of nitrobenzene is, see, do not scare by looking at its structures, very simple and easy. Just hold on for some time, you will feel relaxed by solving this. See, benzene is a, what is its molar mass? So C6H6 na, so it means, so 6 into 12 plus 6, so total mass will be what? 78 gram per mole. This is the molar mass of one benzene, okay, molar mass of benzene. So on nitration giving us nitrobenzene. So nitrobenzene means it will be nitro group here. So what is the molar mass of these? So I can remove one hydrogen, so that I can write 77 plus 14 plus 32. So it will be how much? So it will be 3, 1. So 10, 123 is the molar mass of this particular nitrobenzene. So benzene converted into nitrobenzene. So 78 grams yielding 123 grams of this nitrobenzene. Hope up to here there is no confusion, right? Now given what is the molar, what is the given weight of benzene given? So it is given as 3.9 grams of benzene is given. So now we need to find if the reaction takes place completely, 100% reaction takes place. So we will get for 78 grams we should get 123 grams. So based on this, for 3.9 grams how much weight of nitrobenzene is obtained? If we get this theoretically, we can compare it with this practical data, so that we will get the percentage of yield, okay. So we need to find this x. So x will be how much? So 123 into 3.9 by 78, okay. So I can remove this and I can write minus 1. So this will be 2 times, so this will be 6.15, okay, like this we can write. So what is the weight we got here? So this we got here it as 61.5, right, 61.5. So I can write the weight of nitrobenzene obtained during this process is 6.15 grams. This is the weight of nitrobenzene obtained theoretically. Practically how much they mentioned? 4.92. So percentage yield, you should take experimental yield that is given here in the question, and theoretical yield into 100. So what is our experimental yield? Experimental yield is 4.92, theoretical is 6.15 into 100. So by simplifying this, you will get the answer as 80%. So this will be the percentage yield of this particular nitration reaction. Hope it is also clear. Any confusion, feel free to ask me in the comment box. Okay, and thank you for watching. If you are looking for any particular topic to be covered from our side, you can feel free to ask me in the comment box. I will be doing them in the upcoming sessions. Okay, hope you like the session and stay connected with us. Next sessions will be having for physics, mathematics for MPC students and biology for BPC students. So stay connected with us. Thank you for watching.